Hello friends, in this video we will discuss about the buck converters. This is also called as a step down chopper. So in this category the output voltage VO is always less than the VS, which is a supply voltage of DC. So this is also called DC to DC converter. So the output voltage is always less than the supply voltage. So now we will see the circuit diagram of buck converter, and also we will find out the voltage expression of the buck converter. So for that, first we will draw a circuit diagram of buck converter. This is the switch we will use. High frequency switch we are using, so mostly we are going for the MOSFET or IGBT. One diode is here. Here we are giving supply voltage Vs, and here is the inductor, and we connect the load here. So this is called load plus minus VO. So in buck converter operation we can see the supply voltage is Vs and load voltage is VO. So VO is always less than the Vs. Now we'll see the condition when switch is on. When switch is on, see the operation. So when switch is on, this switch will be short circuited, because in a on condition the MOSFET or IGBT will be conducted. So now this will be short circuit, and here suppose there is a current is flow start here from switch. So here no current will flow, because this diode will act as a reverse bias. So we know that in reverse bias condition the circuit is open, so no current will be flow. And here we know that once the current is flow through this inductor, so it starts to store the energy. This will go minus plus, and the load will be plus minus, like this. So in this case what will happen, the on condition the load current is flow through this closed path, that is IO, and the current across the inductor starts to increase. So if we make a current diagram with time respect, so we can see inductor this current is minimum and this is maximum. So it will go up to maximum in the T on time. So the average current will be delta I is equal to, across the inductor will be I minimum plus I maximum divided by 2. So this current will be starts to flow through the inductor. Now we'll see what will happen in the circuit. So we can apply here KVL. So when we apply the KVL, so we can write here the equation of the voltages. So this is VL. So current starts from rise current minus to positive potential, it will be positive Vs. Then current drops from, voltage drops from plus to minus, so it will be minus VL. And then this is the VO, the fall in the voltage, so it will take as a minus VO is equal to 0. So here we can find out VL value will be Vs minus VO. That is the first equation. Now the next we will see when switch is off. When switch is off. So when switch is off, we can see here the switch will be off, so it will work as an open circuit. And we know that during the on time inductor will be starts to stores the energy, so that when switch is off, inductor will be release the energy in the off period. During that time polarity is reversed, so here polarity will be negative, this is positive, and this stored energy, the current will be flow get the path from here. So what we can get here, this is become forward bias because current will starts to flow from here. So that case it will be work as a short circuit, and this is the load VO plus minus. So in this case we can apply again the KVL. This is Vs, positive negative. So current will be starts to flow through this load, and we can apply here KVL again. So we will get the equation here, rise in the potential, so it will be positive Vs, VL, this is VL, sorry, and here the fall in the voltage, so minus VO is equal to 0. So we can get the another equation, VL is equal to VO in the off condition. Okay, so in this case, in off condition, we can see here the current starts to decay. So this is called the off, this is off period. So again the delta I average current we can find out this. So now we can see during on time we are getting the voltage VO, and this is the on time, and off time there is no voltage. So off time again it will be starts from on to off time. So this is the off time. So this is the area we will get in the voltage VO. So now we can find out the expression of voltage output in terms of supply voltage. For that we have to see whatever the inductor stores the energy in on time, it is going to release in the off time. So energy conservation law, we know that the on time energy on time is equal to energy of off time. So for this expression we can know that energy on time is equal to power on time into T on time is equal to power off time into T off time. Okay, because energy is equal to power into time. So now power we can see through the inductor, so we can write here VL into the average current we are taking here, delta I. So we can multiply by delta I, that is equal to into T on is equal to similarly VL into delta I into T off. So this expression we will get. Now delta I will be cancel out, and we get the value of VL in on condition from first equation, and off condition second equation. We put the value here, so we can write instead of VL here Vs minus VO is to multiply by T on is equal to VO into T off. So now we can simplify this equation. So we will get here we will get Vs T on is equal to VO T on plus T off, and we know that total time period is equal to T on plus T off. So we can write total time. So Vs into T on is equal to, we can write VO into T. So we can write VO is equal to Vs into T on by T, and T on by T is the value of T on, complete T value. This is complete T value, this is time. So we can write here the equation here, T on by T, we can denote it by a delta, that is called duty cycle. Duty cycle delta we can put in terms of T on by T, so we can get expression of delta into Vs. So this is the output voltage of buck converter. So from this equation we can see here very simple thing, that when delta is equal to 0, then VO is equal to 0. When delta is equal to 1, VO is equal to Vs. So in between 0 to 1 delta, we will get the value from 0 to Vs. So it is always going to be reduced than the Vs. So this is all about the buck converter. Thank you very much.